Hi, I'm Sam Dutton. I'm a developer advocate with the Chrome team based here in London. Thank you so much for joining today. So, three things I'll do in the next 25 minutes. I'll give you an overview of the Privacy Sandbox APIs. I'll explain what you need to do now, and I'll show you how you can become a tester and join discussion of the APIs and provide feedback. So let me begin by explaining why we need the Privacy Sandbox. Many of you will know the backstory all too well, but it's worth quickly reiterating why we need this and how we got to where we are today. So the Privacy Sandbox is an initiative to help build a set of privacy-preserving APIs to support business models that fund the open web for a future without tracking mechanisms like third-party cookies. Now, you might have seen this example from Google I/O. It's a typical site with components from different sources. And of course, composability is one of the web's superpowers. You've got a map from one origin, some script from another, and so on. And of course, advertising. And whether we like it or not, and whatever the future holds, advertising has become a crucial source of revenue and a driver for business on the web. Now, at this point in history, I think browsers and CMSs need to support advertising use cases. So, what's the problem? Well, ad selection, conversion measurement, fraud detection, device customization, lots of other use cases have relied on cross-site identity using mechanisms that just weren't built with privacy in mind. Now, not just third-party cookies, but fingerprinting is used to track user behavior across sites, or else sites, request personal information, such as email addresses. And in addition, third-party ecosystems are really complex, especially for advertising. Not even developers, advertisers, or publishers understand the supply chain for third-party services. So certainly when I visit a website, I'm not aware of all the third parties involved and what they're doing with my data. And it's not just me. Research shows that people really care about being in control of their data. Privacy concerns increasingly drive choices about what people do online, and regulators around the world are stepping up privacy requirements. And this is happening really quickly. So, given how many businesses rely on effective advertising online and how many publishers rely on advertising to monetize their sites and a whole bunch of other use cases, this is a problem for the whole web ecosystem and not just for tech companies and ad platforms. But of course, because the web is an open platform, proposals for change need buy-in and feedback. And browsers such as Chrome cannot and don't want to act unilaterally. Browsers are not products for which browser vendors can make decisions in isolation. And the reality is that the web was not designed for many of the requirements that are core to the platform today, for advertising, fraud detection, identity management, and all these other requirements, use cases, and so on. So what we need is purpose-built technologies for this privacy-focused web, and that's where the Privacy Sandbox comes in. So Chrome has been working with the web community alongside industry stakeholders and regulators to develop new privacy-preserving technologies that can support a healthy, sustainable ecosystem. Now, once these new purpose-built APIs are available, we need to make sure companies have time to adopt them so that we can safely phase out support for third-party cookies in Chrome and continue our work to mitigate other types of tracking. Now, the core set of principles for this initiative is the potential privacy model for the web. And this has been developed by privacy experts and computer scientists at Google. This privacy model lays out a set of ground rules for designing technologies that meet the web platform use cases I've talked about, while also abiding by our changing privacy needs. In particular, the proposal covers the difficult question of how to enable connections across sites without compromising privacy. Now, one of the major innovations of the Privacy Sandbox APIs is to enable the browser to act on the user's behalf. In a sense, getting back to the browser's core role as, what we call user agent. With current technologies, data is collected, aggregated, and shared by third parties to track user browsing across sites. Privacy Sandbox APIs can allow ad auctions, conversion measurement, and these other tasks to be fulfilled by the user's browser on the user's device. So we need to rebuild app platforms and the web with collaboration across browser vendors, platforms, advertisers, publishers, ad tech users, regulators, and the privacy community, and not least developers like you working with CMS platforms. So with all that in mind, I just want to give you a whistle-stop tour of the Privacy Sandbox APIs themselves. So at Google, this is a shared initiative across the web and Android. Privacy Sandbox on Android is focused on introducing new, more private advertising solutions without cross-app identifiers. The web and Android, of course, share the same principles, and several of the web proposals are being developed for Android as well. However, of course, the web and Android or mobile platforms rely on fundamentally different technologies. So this is on Android a distinct initiative, but it's one that those of you building Android apps as well as working on the web, you'll want to keep an eye on that. So Google has been testing the new APIs in collaboration with a range of partners globally. Hundreds of companies participating in public forums, either the W3C, the explainer issues on GitHub, and so on, publishing perspectives and analysis and joining industry roundtables, sharing feedback with Chrome and Android, and of course, participating in testing. Now, make no mistake, Privacy Sandbox has a lot of requirements to cover, and it is going to be tough along the way. I think the good news is that at the end of all this, we'll have platforms that are safer and more private for users and better for advertisers, publishers, developers, and of course, for platforms like WordPress. So I'm not going to describe all the Privacy Sandbox APIs. Instead, I'd like to focus on the three main advertising APIs in the Privacy Sandbox. That's topics, fledge, and attribution reporting. Topics and fledge are known as the relevance APIs. Now, topics provides high-level signals of a user's interest based on their recent browsing history. And topics can be combined with contextual signals and first-party data to select relevant ads. And fledge supports more granular remarketing and custom audience use cases, where marketers want to reach audiences who've shown interest in specific websites or products, but of course, to make that possible in a privacy-preserving way. Lastly, attribution reporting is Chrome's proposal for privacy-preserving campaign measurement, providing anonymized performance reports. And when people view or click on an ad and then later go on to complete a purchase or some other kind of conversion. So these APIs have been through a period of testing in Android and in Chrome on desktop and mobile. If you are working with ad tech platforms, you need to make sure you understand those platforms' plans to address these use cases. And the use cases that are being met by these APIs for this future without third-party cookies or other tracking mechanisms. So now we've had a period of technical testing with the APIs activated using Chrome flags, and now in Origin trial initially activated for only a small percentage of Chrome users initially. So now we're at the stage of utility testing. 50% of Chrome Canary Dev and beta users have the Ads Origin trial APIs activated on pages that provide a valid token, and 5% of stable users. Now, that's a small percentage of overall Chrome traffic, of course, but it's enough for limited testing of the APIs with real users. Now, we're now moving towards launch in Chrome Stable, where the APIs will be available for all users by default, and I'll come back to the timelines for that later. So just to reiterate, for a single user, you can activate the APIs using Chrome flags, but for testing at scale, you need to take part in the Privacy Sandbox Origin trial. And I'll share links later for guidance on how to do all that. So by the way, Chrome is also updating user privacy controls, like the UI for this. And the Privacy Sandbox controls are actually available as part of the ads API's Origin trial. People will be able to see and manage the interests associated with their browsing or turn off the APIs entirely. So there are actually 3 other Privacy Sandbox technologies I think you may also want to test, or certainly flag up to any of your third-party providers. Firstly, chips, that's cookies having independent partitioned state, allows developers to opt in a cookie to partitioned storage with a separate cookie jar per top-level site. First-party sets allows related domain names owned and operated by the same entity to declare themselves as belonging to the same first party. And private state tokens. You might have heard of this. The initial name was trust tokens. This is an API to convey a limited amount of information from one browsing context to another, for example, across sites, to help combat fraud, but without using passive tracking techniques. So first up, let's take a deeper look at the Topics API. The Topics API provides a mechanism to enable interest-based advertising, but without allowing third parties to track user browsing activity. So the API, in a sense, has 3 major components. And first up, interest-based advertising needs a taxonomy of topics of interest. The Topics API taxonomy looks like this. It's a publicly maintained human readable list of topics that avoids sensitive topics. And now this is likely to change and develop over time in consultation with the web ecosystem. And that means people like you, we need your feedback with this as well as everything else. So the Topics API needs to infer interests for a user based on their browsing activity. But as I say, to do that in a way that preserves their privacy. So the top topics of interest are recorded for a user in their browser on their device based on their recent browsing activity. Again, by their browser on their device. Now, at present, Topics does that by using machine learning to map the host names of pages the user visits to topics from the taxonomy. Now, as with the Topics taxonomy itself, that approach will develop over time. But inferring interests from browsing activity, needs to get the balance right. If you have too much detail about user browsing, well, that's bad for privacy, but too little granularity means the API isn't useful. I think, in a sense, the main thing to understand here is that topics of interest are just one signal for finding what's relevant to users. So now, once topics of interest have been inferred by the browser for a user, Topics needs to provide API callers with access to the topics of interest that they've observed for the user. So as the user navigates the web, there are 2 stages to the API. An API caller, like might be an ad tech platform, for example, calls the API on a page to signal that they want to observe topics for the current page and the current user. Now later, the API caller can access the topics that they observed for the user. Now all of this must be done without revealing anything more about the user's browsing activity other than the topics of interest that were observed. So the Topics API provides 2 ways to observe topics of interest for a user and then to get access to those topics that were observed. Firstly, with a JavaScript API or by using the request and response headers on a fetch request. The first way that a Topics API caller can signal to the browser that it has observed topics for a user is to call document.browsingTopics from an iframe embedded on sites the user visits. Now later, the API caller can call the same document.browsingTopics method to access topics that it has observed for the current user. And the reason this method needs an iframe, by the way, is that the context for observing topics must be the same as the context for accessing topics. The other way to observe and access topics is to use fetch, request, and response headers. First, the API caller needs to make a fetch request to a URL on its origin, including the browsing topics true object in the options parameter. And if the response to the fetch request includes an observe browsing topics ?1 header, well, that signals to the browser that the caller wants the browser to record that the caller has observed the topics of interest for the current user for the current page. I hope that makes sense. Now, topics observed for a user can be retrieved from a caller's fetch request by accessing the sec browsing topics request header. So here's the whole process from start to finish. I'm conscious of time, so I won't go through it now, but we will share this later so you can see how that works, the whole process. We'll have that for each of the APIs. And you can try out a topics demo that uses the JavaScript iframe method to observe and access topics, or you can try out our demo that uses the fetch request header approach. Chrome Topics Internals displays topics for the current user, topics conferred for host names, and technical information about the API implementation. You can also run the topics co-laboratory to test topics inference using the topics classifier model. Now, 3 major open questions for you before I leave topics. How could we do a better job of inferring topics of interest for a user based on their browsing activity? How can we improve the taxonomy, content, and structure to make it more useful while preserving user privacy? And how can we improve the overall architecture of the API? I think one thing to bear in mind here is, whether we have topics or something different, we still need to meet its use cases. Next up, Fledge. So this is an API for on-device ad auctions to serve remarketing and custom audience use cases without the need for cross-site third-party tracking. I'm going to go into a tiny bit more code detail with Fledge because it has a more complicated job to do than topics. So there are 3 parts to the Fledge process. First, the ad buyer adds users, or rather kind of individual browsers really, to what are called interest groups. These are like custom audiences, but interest group membership is stored on the browser on the user's device. Now, at some point when a user visits a site that displays ads, such as a publisher site, an ad seller can initiate an ad auction to select an ad for them. And with Fledge, this auction can be run on the user's device. To select an ad, the auction code runs bidding logic from buyers and auction logic from the seller. And lastly, the browser does post-auction reporting to endpoints supplied by the sellers and buyers. So I'll just go through Fledge step by step very briefly. Firstly, imagine a user visits an online shoe store, does some browsing. An ad tech platform, or maybe an advertiser themselves, makes a JavaScript call to tell the browser to join an interest group. And this group might be named something like trail running shoes. The configuration object for an interest group might look like this. In this example, the shoe store's ad tech might have an interest group for remarketing that they'd like to add the user to. And they've called this group, trail running shoes. And the shoe store's ad tech platform calls join ad interest group to ask the user's browser to join their trail running shoe interest group using that configuration that I just showed you. And the second parameter specifies the duration of the interest group, which is capped at 30 days. Now the user visits a site that publishes ads. In this example, a news website. An auction to select an ad to display to the user is run in JavaScript on the user's device by the seller using run ad auction. And the seller is probably an ad tech platform, but maybe the publisher itself, in this case, the news site. Now, this auction selects the most appropriate ad given bids for each of the interest groups the user's browser belongs to, along with other factors from the seller and the browser itself. Now, looking at the code, the publisher or a platform selling ad space on the publisher site creates config data for the ad auction. The seller then asks the browser to run an ad auction to select an ad, in the browser. And the value returned by run ad auction is passed to an element called a fenced frame, so the site can display the winning ad. Now, a fenced frame can be used to display an ad, but it cannot interact with the page around it. And then the seller and the winning buyer each have an opportunity to perform logging and reporting. And that's done by calling navigator.reportResult. Finally, the user, if all goes well, taps or clicks on the ad, and now the attribution reporting API takes over. And again, we have a diagram showing the whole process from start to finish, which we'll share with you after the keynote. Now, lastly, I'd like to tell you a little about the Privacy Sandbox API for ad measurement, which is attribution reporting. Attribution reporting is used to measure when an ad click or an ad impression leads to a conversion. For example, when a view of an ad on a news site leads to a purchase at an online shoe store. Now, as with Topics and Fledge, this API is designed to avoid cross-site tracking. So the API allows two types of measurement results: event-level reports and summary reports. So let me describe briefly how that works. First, let's take a look at event-level reports. So ad links can be configured with attributes that are specific to the attribution reporting API, and this makes it possible to tally views and clicks with a request on the conversion side. Now, when a user clicks an ad or sees an ad and then converts, the browser generates a report. And in that report, the advertising company or ad tech includes two pieces of data. One, any data they want about the ad click or impression. And this can be very detailed, for example, a creative ID, information about the publisher, the timestamp, and so on. And second, a small piece of data about the ad conversion. Now, to protect user privacy, this cannot be too detailed. And later, the browser sends that report about, that report with the data I just explained to the ad tech or the advertiser. And that includes a delay to help avoid user tracking. The report contains two pieces of data: detailed data about the ad click or impression, the event, and high-level data about the conversion. So this is an event-level report. Now let's take a look at summary reports. Now, the browser API to generate a summary report is similar, but the results and the mechanism are a little different. So again, when a user clicks an ad or sees an ad and then later converts, the browser generates a report. And in that report, the advertising company or ad tech can include any data they want about the ad click or impression and any data they want about the ad conversion. But this report is encrypted, and this is a privacy protection because this report contains detailed data about the conversion and the impression. So the report could be used for cross-site tracking if it wasn't encrypted. Then later, the browser will send this encrypted report again with a small delay. And in this way, an ad tech platform will collect many reports from many users and then send all the reports to an aggregation service, as it is called. And this service will aggregate all these reports, decrypt them, add some noise to protect user privacy, and then return the final result. And the final result is called a summary report. It contains measurement data for many users. So that's attribution measurement. I hope that makes sense. I'll link to lots more resources to help you understand and test the Privacy Sandbox APIs in more detail. But one last thing I'd like to mention, Privacy Sandcastle. This is a demo that combines all the main Privacy Sandbox APIs. It's been built by our team in Tokyo. It's still very new, but you can get the code from GitHub and run it locally. And it's designed to help you understand how all these APIs fit together. Before I finish, I'd just like to take a recap and look at the timeline for Privacy Sandbox. As you can see, we are approaching the quarter where we will begin shipping the APIs, meaning they will be available by default in Chrome Stable and ready for testing at production scale. Now, that's only a short amount of time on the calendar, and I can see myself, I'm close to time here. So a few things that I think you need to do right now. Firstly, understand the timelines for web and Android. Make sure you and your third-party providers are prepared for the changes that are now imminent. Secondly, audit your sites to understand where they rely on third-party cookies and other mechanisms that are being deprecated. We will share links to tools and instructions for how to do that after the event today. Next, ask your third-party providers, such as ad tech platforms and so on, how they are preparing to meet their core use cases in the absence of third-party cookies or other cross-site tracking mechanisms. And lastly, test the Privacy Sandbox APIs and provide feedback, and ask your third-party providers to do the same. And if they're not, well, ask them why not, and let us know what the answer to that question is. So privacysandbox.com provides timelines, FAQs, more information about cross-platform efforts. I'll share URLs after this event, but you can find a lot of the content I've referred to here from the Privacy Sandbox section on developer.chrome.com. In particular, this has resources that explain how to ask questions for us and to provide feedback. And you can find out more about Origin trials on developer.chrome.com. We've also created a series of short videos and articles to help explain Chrome concepts, like stuff like Origin trials, Chrome flags, blink intents, all that stuff. So, thanks for listening. That's it from me. Like I say, if you do need support, please, go to those resources, or you can just direct message me, SW12 on Twitter. Thanks so much.